Alright, so today we're going to be making a command line version of the classic game Snake. And as you can see, I have it running here just in my terminal. All I have to do is run this Python script that I wrote here. And I'll walk through the code and how you can actually build a script like this from the ground up to be able to play a game like this without any like animation tools or anything like that. Alright, so I'm going to start off with this line that you should typically include if you're making a Python script. This is sort of like where the main method goes. And for now, I'm just going to pass because it's not doing anything yet. And I'm going to create a class called game. And for this, we need to create an init function. And we'll pass in a width and a height. And this game is going to store an internal state as a two-dimensional list. This will make more sense in a little while. But to make this, we'll just say for row in range height, row equals empty list, and then for column in range width, row dot append none, and then outside that inner loop, we'll append to the grid the row. So now we just have a row of length width full of nones. That's for each row. And then all those rows make up the list of the grid. And then we're going to set self.grid equal grid. So now this game has like an attribute called grid, and that equals this two-dimensional list that we just created. And so now I'm going to create another function in game called display. I like to create the display function early on so I can kind of see what's going on. This will take self, and it doesn't need anything else, it just needs to know about its own grid. And then I'm going to start by defining a function inside here called print border. This will take a symbol, and we'll set this variable line equal to an empty string, and say for I in range width line plus equals symbol. And then we'll print the line at the end. And this width variable isn't actually anything. So I think what I'm going to add here is attributes to the game of width and height. So now I can say self.width in here. Cool. So then outside this print border function, I'm going to start by calling print border. And that'll be our top border. And I'm going to call it with an underscore. And then I'm going to print a border, the bottom border, with a dash, because that's sort of the highest horizontal line I can make. And then we're going to do some stuff inside to create the left and right edges of the board. So we'll say for row in range self dot height. And then the first, the left border is pretty easy. We'll just print a vertical pipe. And actually, let's make sure that we set end to empty string rather than new line. And then for column in range self.width, we can print a space, set end again. And then outside this loop, we can print our vertical bar. And that should be a good start. So if we try running this program, well, we don't see anything yet because we have to add this to our main function. So let's init a game with some width and some height. So equal to game, and then let's try game.display. Oh, so that looks interesting. I think maybe what's happening here is this width is too wide. Oh, cool. And actually, let me clear and show you again. So it's almost right. I think maybe what we should do here is decrease the number of spaces in here by a couple. Sweet. So that actually looks pretty good. So now, depending on these values, we can create a board of however big we want, and it'll display itself. And actually, instead of hard-coding numbers in here, let's create some constants at the top for width. Let's say 40, maybe 45, and height, maybe 25. So this way, we can init the game with a width and a height. And it still works. That's probably better proportions. We can really just sort of fill up the screen here. Sweet. So we've got a nice board here. That's a good start because now we'll be able to see what's going on. Alright, so now we're going to actually start working with objects on the board. And actually, I'm going to make this font a little bigger so it's easier for you to see. But in order to start working with objects, I'm going to create a class called square. And this will just represent like a given square on the board. And I'm going to use some keyword arguments. I'm just going to call this coordinates. And so we'll say x equals coordinates dot get x, oops, default's none, y equals coordinates dot get y, none, and then we'll say something like if x equals none, x equals random dot rand int from 0 to width. And actually this is going to be self dot x. It'll be an attribute called x. Otherwise self dot x will just be set to x. And we're going to do the same thing for y. Self.y equals random.rand int 0 height. Else self.y equals y. And we're going to have to import random to be able to do this. Cool. So now we have a square where you can pass in coordinates when you create it, and it'll set its own x and y value to those coordinates. And if you don't pass in coordinates, it'll just generate them randomly. So now that we have a square object that keeps track of its own coordinates, we can start working on our snake class. So we'll def init, and this will take a direction and then an optional array of segments. And the way our snake will be defined is as having a body, which will be a list of squares. And each of those squares will have its own coordinates, x and y. So we can loop through segments. For segment and segments, self.body.append. And what we're going to do is actually append the segment and a direction that goes with it. Because if you think about it, our eventual intention for the snake is not for it to be moving in one direction. Like its head will be moving in a certain direction, but other parts, other segments of its body may be moving in their own directions. Because the snake should be able to twist and turn. So each segment will be a set, like the square. So we could actually call this square and its direction. And the fact that we're taking this list of segments is not really necessary, because when we init our snake, we're probably just going to init with the first segment and its direction. So this could just take one segment instead and append that segment and the direction. But this is a little more flexible. It lets us pass in multiple segments. And now we want our snake to be able to move, but instead of actually defining the move function, I'm going to define sort of a helper for the move function called shift square, because the move function is going to be a little more complicated and involve some logic, but we want this one to be very straightforward. And it will actually take a square and a direction. And so we'll say if dir equals up, square dot y minus equals 1, elif dir equals down, square dot y plus equals 1, because this is sort of like the origin starting point up in this left corner. So increasing y is bringing it down, decreasing y is bringing it up. And this will go for left and right as well. Okay, and I'm actually going to change something here. Right now I'm representing directions with just uppercase strings, which is fine, but I'd like to be sort of a little safer here. So I'm actually going to define constants where like up is just the string up and so on. And this allows us to at least like catch it more easily if we misspell a variable. We'll get like a name not defined error rather than like a direction that doesn't make sense. And it's just, I'd rather deal with the constants anyway than the strings. So then we can like replace these with the constants. Great, so now this function will just like take a square and a direction, and depending on the direction it'll move that square. Okay, so now this is a good point to introduce our keyboard listener. So we're going to import from PyInput something called keyboard, and we're also going to define a function up here called onPress, and it'll take a key and like do something based on what that key is. And this will be passed in down in our main function as a callback function to this keyboard listener that we'll use from this keyboard library. And I should actually point out here that in order to get this to work, because I'm using a Mac, I had to go into my settings and go into security and privacy, and then under accessibility, I had to like add the Python language and the terminal application that I'm using in order for this input library to be able to work properly, which was really annoying actually. It took me a long time to figure out why it wasn't working, but apparently on Windows computers this isn't a problem. Anyway, the way this works is I'll put a try statement in here, and I want to check if the key pressed equals some key that we have mapped to one of our directions. And so the way I'm going to do that is create another constant up here called keyDict, and this will be a dictionary with like whatever key I want to be mapped to a specific direction. Whoops. So if I map like W to up, S to down, A to left, and D to right. Cool. So now like the keys are both the keys in the dictionary and the actual keyboard keys that you would press that are mapped to a specific direction. And I would use like the arrow keys instead of W, S, A, D, but this input library isn't as amenable to that. It is really easier to use like letters on the keyboard. Anyway, now I can set our direction to be whatever the key pressed is in our keydict. And I can say something like snake dot shift square in that direction. And then I'll want to catch a couple of errors here, a key error, an attribute error. And these could arise based on this key library and what I end up pressing. And in that case, I'll just return false. Cool, so now I have this like pretty simple onPress function. And the way I can use this is down here in main. And actually one more thing, because I'm now doing something to the snake inside of my onPress function, I'll have to pass snake into my onPress function. And this is a little bit, it's like slightly tricky because the way this onPress function is meant to be is to just take the key. And I'll show you how this works in a second, it'll make more sense. But first, to understand that context, we have to go down to the main function and actually apply this onPress function that we just created. So to do that, I'll create a keyboard listener. So this will be keyboard.listener, and then I'll pass in an onPress function. And this is just a keyword. This listener constructor takes an onPress keyword argument. And now normally, so this is what I was talking about a second ago, I would just do this, but that would assume that this onPress function only takes a key. But since we want to also pass in the snake, we have to do something a little fancier. So instead we'll use a lambda anonymous function, pass in the key, because this onPress expects a function that only takes a key. And what it'll do is actually call our onPress function with a key and a snake. And then we can say listener.start. And I'll have to actually like create the snake that is being passed in here. So let's do that up here. So we could say snake, give it a direction, and we can actually call square with no arguments, because if you give it no coordinates, remember, it just generates random ones. So that's actually a good way to have a starting snake. And actually we should also start with a random direction. So we should write a random_dir function. So let's do that now. And that doesn't need to go inside either of these classes. Just like onPress, that can be out at our top level. So if we create random_dir, it doesn't need any arguments. What we can do is actually enumerate our list of dirs up here as a list. And left. And then we can just return dirs at some random index. Lenders -1. Cool. So then down here, we can just pass in a random_dir. Sweet. And now for the fun part, we'll actually want a while loop that sort of runs our game. For now, we'll make this while true. It won't always be that way, but it's a good way to start. And this is where it'll get kind of cool and we can show how the movement works. And the way this is going to work is we're just going to basically update the positions of things at each iteration of the loop, and we'll sleep for some small amount of time at the end of each loop. So it'll look like they move at some speed. And we'll also clear the screen so that we don't see, like we only see the board at each time. So we actually want one more top level function called clear screen. And for this, we'll just say for I in range, 50 or something. We can just print a blank line. So then while true, we can start by clearing the screen. Then we can display the game. And actually, I'm going to change the random_dir. I'm going to put it in a variable named starting_dir. So this way we can actually keep keep track of what that was, just for the sake of using it down here. Whoops. So we can like call snake.shift square in the starting dir, and then time.sleep. And let's make this another constant called speed, which we can put up here as something like 0.2. And so the way this works is this listener is asynchronous. So it's like it's running on its own thread, like waiting for a key to be pressed at the same time that this while loop is just doing its thing. And our shift square function actually takes a square and a dir, not just a direction. So maybe instead of doing this, we should just write a basic version of our move function for the snake. And this can just like iterate through the segments of the snake's body. And remember, these are actually squares and dirs. And we can just shift them. Now we have the square and the dir. And if we're going to do this, this onPress function is going to be quite right either. Because what we want to do with this is actually like turn the snake in some direction. So we also need a turn function. And this, for now, can just like change the direction for the segments. So it can take a dir and self.body. We can start with just the head. So we can say like square old dir equals this. Now self.body 0 will equal square and dir. Okay, so both the move function and the turn function are going to end up being different from this, but this is a nice little starting point just to see if we can get our movement working. And because each segment of the snake's body has its own direction that it keeps track of, we don't actually need to pass in move a dir. And we also need to change this to self.shift square. And I also forgot to import time. Let's do that here. And if I try running it, it doesn't end instantly. Like either the while loop and or the keyboard listener are running right now, but we're not seeing anything. And the reason for that is we need to add something here to the game class, and that is the snake. Right now we're displaying the board, but we're only displaying the borders. So we've added this snake argument. We can also set self.snake equals snake. And then in our print function for square dir in self.snake.body, if square.x equals column and square.y equals row, we want to print whatever our snake symbol is. And actually, this will be another constant. So we can change that at the top if we want. Set n equal to empty. And we're going to also create a boolean called empty that we'll set as true. And inside this case, we will set empty to false so that we know down here not to print a space. We're only printing the space if we never saw the snake square. So now if we add the snake to our game init function, or init call, and we fix this error up here, and then we try running it, it'll tell us that we never created the constant. Let's do that right here. Equals, let's make our snake symbol a capital X. Awesome, so now we have an X that moves, and it actually changes direction whenever I press an arrow key. Not an arrow key, but one of the keys that I assign in my dictionary. So this is a good start. And what it's doing is it's just printing a bunch of frames and clearing space between them, so it looks like there's just one constant board and X is moving inside it. So this is pretty cool. This is a good start. Alright, so now that we have our basic movement working correctly, let's look at generating the food, like the square that will randomly generate itself and can be eaten by the snake so that the snake can grow. So we're going to add this in the game class. We're going to create a gen food function, and what it's going to do is it's basically going to like loop and generate random coordinates until it finds coordinates that aren't occupied, which will usually be the case, but we want to avoid like picking a spot that's already taken by the snake. So we can define a function inside here called already occupied, and it'll take 2 coordinates, and we'll create a boolean called occupied. It starts as false, and we'll say for square dir, and I'll underscore dir here when I look at self.snake.body because I'm not going to be using the direction, and this is just like a convention I like to use to like explicitly state that this variable will be ignored. Anyway, as we loop through here, we'll say if x equals square dot x and y equals square dot y, occupied becomes true, and then after the loop we'll return occupied. So this will look at each segment of the snake, and if it finds one that's at these coordinates, it'll return true. Then outside our function, let's create some little one-line lambda functions that take some value and generate a random int from 0 to x minus 3 because these borders take up a couple of spots. And then for gen y, we can also make a lambda function that will generate between 0 and y minus 1. And the reason these numbers are slightly weird is just like the sort of idiosyncratic definition of how we had to display our board, with these corners being kind of weird and these horizontal lines kind of being cut off here. So then we can start by setting x and y using width and height. And then we can loop until we get something that's not already occupied. So x equals gen x, y equals gen y, height. And at the end, we'll set self.food equal to a square. And actually, one thing we can do to improve this is instead of having to say this, we can actually redefine the square, the built-in square.equal function. So in the square class, we can say eq self other, and this will just say, if self.x equals other.x and self.y equals other.y. So if both of those are true, the squares will in fact be equal because all we care about is coordinates. And that'll be useful in a couple other cases throughout this program. But that way, down here in our gen food function, we can just put a square in here instead of coordinates, and actually, we can call this snake square. So if square equals snake square, cool. So that looks a little nicer, and then this can just be the square of xy. Sweet. So now we have a gen food function, and we can actually add this to our init function in the game. So we just call self.genFood, and then when we create the game, it'll automatically generate food somewhere. And I forgot that our square init function takes keyword arguments, so we actually have to say x equals x, y equals y. And now we just need to add our food to our display function. So now in here we can say something like if self.food.x equals column and self.food.y equals row, print food symbol, and it's empty, and empty equals false. And then we actually need to nest this in an else statement. Well, maybe we don't actually need to, because the food should never be generated where the snake is. And at some point the snake will collide with the food, and we'll have to handle that in just a little bit. But for now, I can just fix this and declare what food symbol is. Let's make it capital O and try not to make this spelling error again. And now if we try to run, we see the food. Now we haven't handled any logic for if they collide, so the snake just kind of goes through the food. But the food is there, which is a good start. So now that we have a program that works a little bit, as you can see, that was a bug right there. It goes outside the border. We've seen that it'll go right through the food. So clearly there are still plenty of issues with our program. Particularly, our snake doesn't know how to grow yet, and we'll also see that when it does grow, turning becomes a little more complicated. But for now, we have some nice basic functionality. So this will conclude part 1, and I'll be making a second part 2 video to finish up this program and show you the rest of the code. But if you can't wait till then, the code is all on GitHub. I'll link to it in the description. And aside from that, I hope you enjoyed this video, and if you want to see more content like it, please like and subscribe. Thanks for watching.